Hi guys, let's solve today's Leetcode problem, which is problem number 2540, minimum common values. It's a easy problem. Given two integer arrays, num1 and num2, sorted in non-decreasing order, which means it's an increasing order sorted array. Return the minimum integer common to both arrays. If there is no common integer amongst nums1 and nums2, return -1. Note that an integer is said to be common to nums1 and nums2 if both array have at least one occurrence of that integer. Okay, so let's see this example. Here nums1 has 1, 2, 3 and 2, 4. If we see the common amongst this, the minimum common, that is 2. Okay, though the minimum value in this array is 1, but that is not present in this array, right? So the minimum common available for this array is 2. Okay, so that is the answer. If you see in this array, again the same, 1 is not here, so 2 is answer for this one also. Okay, so that is the question. And if you see the constraint nums dot length and nums2 dot length, it's 10 to the power 5. So normal brute force won't work. That we will we can have two loops. One is iterating over the first array and second is iterating over the second array and finding the values over here. Okay, so that is basically O of n into m time complexity, and that won't work given the constraint. Okay, so for that reason we will consider a few approaches which is possible for this array, and we'll know which is the best one for this. Okay, so first is using hash set. Hashing will do the set. Another is using binary search, and third is using the two pointer. Now let's get started with set approach. So what we can do is we can add the elements of first one array into the set and search for the elements of the second array into the set. Okay, so in this example, if I say that this is my set, okay, and if I put these values into my set, so it would be 2, 3, 4, 5. Okay, now what I can do, I can start iterating over this array. I can see, okay, 1 is 1 in the set. Okay, 1 is not there in the set. Is 2 in the set? Okay, 2 is, yes, 2 is there in the set. So this is the minimum value. Why this is minimum? Because we have given this array in the sorted manner. Okay, so this we are basically searching for this minimum value in this array into this set. So this is the minimum common value amongst this. Okay, so one was we added this value into the set, and another is we are searching on the another set of arrays, I mean elements in the array into the set. So that was the straightforward approach. Okay, now let's check the code for this. So code is again very simple. We have two array 1 and array 2. We have taken the size in n and m variable, and we have created an unordered set. In first step, we are putting the second array, that is of size m, this one, into the set. Okay, this is we have added the values into set, and the second iteration is about uh, basically searching this elements of a1 into the set. So we are searching if st.find a1 of I is not equal to st.end, which means this value exists in the set. If so, then we can return directly a1 of I. Okay, which means the first element that we find which is common in both the arrays, which will be minimum, is there in the set. So yeah, we can directly return from here. If after iterating for all the elements in a1 we didn't find any values in the set, then at the end we can return -1 saying no value exists. Okay, so that is the straightforward approach. And if we discuss the time complexity, so this is the insertion time in the set that it will take, that would be of O of n, and this is the another time that it would take for iterating over the array. Okay, so this is O of m plus O of n. Okay, so time complexity is O of m plus n. Okay, now space complexity, if I say, so I mean not exactly a space complexity, we have taken this set, right, set data structure, which will be of size m. So space complexity is O of m. So yeah, that is the space complexity. Now we see that this space complexity is something which we can definitely improve on. So if we don't take any space, how can we solve this problem? We have to further approaches, right? So one approach, you remember, right? At the starting, I said that we have this array 1 and this array 2. I said that we will pick one element and iterate over this array 2 and try finding this element over here. Okay, so that was the initial approach that I told. But in this, we are first iterating on this one loop for this and the second loop for this one, right? Which will be O of m into n, right? But if you see that we know that both the arrays are sorted, right? I need to take this, pick every element and check in the set in this second array. But since this array itself is sorted, do I really need to do a linear search? I can simply apply binary search over here, right? So same thing we'll do. Instead of searching linearly on the second array, we will do a binary search over there. So as said, since both array are sorted in ascending order, we'll iterate over one array and search that element on the second array using binary search. So here we start, we have this element 1, so we'll search for this element 1. Okay, so it's the normal binary search. We'll put all this pointer low, high, then this value would be mid, and then we'll see if this mid value is greater than or less than or equal to whatever it is. In this case, if you see, this 1 is less than this mid value, which means we have to move our high pointer. Okay, so when we moved our high pointer came here. Then we'll apply further. Again, the same value will be mid again. So if we see the value is again less, so we'll move our high pointer over here. Okay, which will be -1, pointing to -1. Now, if you see this low value is greater than high, okay, then at that point we will break our loop, that we were not able to find this value 1 into this array because that value didn't existed, right? Now this is for this 1. So for this we didn't find our value. Okay, now we'll search for 2. So again, same things, low, high, mid. Okay, we search this value mid. This is again mid, value is greater than this 2. So we will move our high pointer. When we moved our high pointer over here, so we see that this will be our new mid. Okay, so we see that array of this value is equal to this mid value, which means we have found our answer. So directly we can return this value from there. And at the end, after searching for all these values into this array using binary search, if we are not able to find, simply will return -1. So that's as simple as that. Now let's check the code for this. So same things as above, two array sizes mn. Now iterating over the first array and keeping that into a value, variable called value. And we have this pointer low, high. Since it is m-1, as we are doing binary search on the second array, which is of size m. So now while low is less than equal to high, this our mid pointer is, we are calculating the mid value. And if this array of mid is equal to this value, which means we have found our answer, so we return this. If this value is less, okay, mid is less, then we need to move our low pointer to mid plus 1. Basically we need to increase our values, right? Because this value was greater, so we need to find the value in the greater side of the array. If not, if its value was less, then we need to find in the second lower side of the array, okay, in the left half basically. So we moved our high pointer to mid -1. At the end, if we didn't find, we return -1. So that's a straightforward, I mean, it's very simple binary search approach over here. And if we see the time complexity, so it is, we are going over the first loop, which is of size n, and then another loop inside that will take log of m time complexity, okay, for checking for all the elements in the first array. Okay, so that is the time complexity. But space complexity, if you notice, it is O of 1. We reduced on space for sure. Okay, so yeah, that's all. But if you see that again, time complexity, I think we can further reduce it. This is not not really needed, because we again have to think in the manner that we have given the both the arrays are in the sorted array, sorted manner. Okay, so you have to make use of that. Okay, we made use of one array which was sorted by applying binary search, but since both of the arrays are sorted, so we will use some things. Okay, now since we know that both the array are sorted in ascending order, so if we apply directly two pointer, as in putting one pointer I over here and another pointer j over here. Now instead of searching for one values one by one using the binary search, I mean one value and searching in the remaining array, we know that since this both the arrays are sorted, the minimum will lie um at some pointing I mean at some point over start only, right? Why? Because if you see that this, if this value is less, what I need to do, I need to move this pointer, okay, to find the value which are which so that both the pointers come to the same page, basically same equal value, right? If this value would be less, then we would move this j pointer ahead. Okay, so same way we will keep, if this value I was less, then we will move j. If this value j was less, then we will move I. Like that we have to keep on doing, okay, until we find the minimum value. So if we do two pointer iteration over here, so we started with 1 and our I mean I and j, this value 1 is less than this value 2. So what we need to do, we need to move our I pointer over here. So now if we do the comparison, now both the pointers are pointing to the same value, we can return. So if I say this was a very straightforward example, maybe if I take some other example, so let's make it here, let's keep it 2, and here let's keep it um, 1, 1 and 3. Okay, now let's apply. So here I, here j, both are sorted. So we started with this value I. So we check this value j. Now, if you see this I is less than this, I is greater than this array of I is greater than this value. So we need to move our j pointer because this is smaller, right? We have to match. Now, again, if we do the comparison, again it is smaller. So we will move our j pointer further. Now we see that now, if you see this value 3 is greater than this value, which means now this value is smaller. This pointer I, wherever it is pointing, this is smaller, so we need to move our I pointer. Again we compare, it's again less. Then now if we compare, we came to the same page where this both the values are matching. Okay, so for that reason, after this new array that I created, for that answer is 3. Okay, so this is the very simple approach. When the values are equal, then we return. If the value is less, the whichever is less, we increase the that value, okay, that pointer. If this value was less, we moved this pointer ahead. If this value was less, we moved j pointer ahead. So the same way we have to just keep on doing. Now let's check the code for this. We have this two array of size this and this two pointer I and j. Now we are iterating here. While I is less than j, I is less than n, and m is less, j is less than m. Okay, this check is very important so that we don't exceed. And at the end, if we finished any one of the array and we were still not able to find, which means there is no common element at all in this array. Okay, so in these two arrays, so we can return -1. Now, as I explained above, if array of I is equal to array of j, second array of j, so in that case, we can directly return array 1 of I. Okay, if this array 1 of I is less than array 2 of j, which means this value is less. So in order to match both the values, I have to move I pointer. Otherwise, else array of 2 of j is less than array 1 of I. Okay, which means this value was less. Then in that case, we need to move our j pointer ahead. As simple as that. Okay, so yeah, that's all for this approach. Now, if you see this loop, so it can time complexity, if we see, right, so it can be something, our move our j pointer is was here, let's say, and we, to match this value, we moved our I here, here till the end. Okay, and now at here there is something which may be matched or which is greater, let's say. Now for to match this value, we again need to move our pointer j. Now all till I value moved all till here and j value moved all here. This is the max no, that can happen in the worst case, that we needed to move both of the pointers till the end. Okay, in this case, if you see, what would be the time complexity when we move to needed to move both of the pointers till the end? So it is nothing but O of m plus n. Okay, now space complexity, if you see, so we have reduced the space complexity to O of 1, as we are just taking a few variable as pointers, nothing other than that. So yeah, that's all for this approach. I hope you like this video. Thank you for watching. Stay tuned for next videos.